I'm standing on Blackheath Common in southeast London. But if I wanted to tell someone my exact location, how would I describe it? I could say I was 500 metres south of Greenwich Observatory, but that would only be useful to people who already know where the observatory is. I could use the address of the nearest building, but that's several hundred metres away, so that wouldn't be very accurate. One reliable way to describe where I am is to use a pair of coordinates. Now, coordinates are numbers that specify a location on the Earth's surface relative to an agreed reference point. There are lots of different coordinate systems, but probably the best known is the geographic coordinate system, which uses latitude and longitude. That's the system underlying every GPS-enabled device that you own. Latitude is a measure of how far north or south of the equator a point is, while longitude is a measure of how far east or west a point is relative to an imaginary line drawn through the Greenwich Observatory, which is just over there. The geographic coordinate system is used in lots of applications, but one difficulty with latitude and longitude is that they are usually measured in degrees, sometimes called decimal degrees. A latitude of 0 means a location on the equator, while a latitude of plus 90 degrees means a location at the North Pole. But degrees aren't very useful for measuring everyday distances. It's not very informative to say that the nearest railway station is 0.01 degrees walk from here. Because degrees of latitude and longitude aren't easy to work with, it's often easier to use a different type of coordinate system when making maps. These are called projected coordinate systems, and they work by specifying a location relative to a well-defined starting point that isn't the equator. There are lots of different projected coordinate systems that cover different parts of the Earth's surface. For example, for locations in London, we can use the British National Grid system. This specifies locations based on how many metres they are north and east from a specific point in the Atlantic Ocean off the coast of Cornwall. Because the British National Grid measures distances in metres, it's easier for us to work with. We will use coordinates specified in lots of projected coordinate systems during this course. But there is one drawback to projected coordinate systems. The people who design them have to deal with the fact that maps are flat, but the surface of the Earth is curved. We don't need to go into the mathematical details of how this is done, but it's important to know that there is simply no way to accurately represent a curved surface on a flat map without some sort of distortion. And there are lots of different ways to manage this problem. Which solution is best depends on the circumstances, so people designing projected coordinate systems for different parts of the globe might make different decisions. That has two consequences for us as map makers. Firstly, we must know which coordinate system a particular dataset uses. Knowing a pair of coordinates is useless unless we also know the coordinate system. Most spatial datasets have this information embedded in them, but if not, then it's vital that you find out what coordinate system the data uses. One way to do that is to ask whoever provided the data what coordinate system they used. The second important point is that projected coordinate systems only work for the part of the globe that they were designed for. If you use the wrong coordinate system, or use a coordinate system for a different part of the world, it's quite likely your map will have errors in it, or some of the features will look distorted. For example, you probably recognise this outline of the UK. But if you told a computer to transform that outline using a coordinate system designed to make maps of Canada, for example, you'll see the outline becomes distorted. Dealing with coordinates can sometimes seem complicated, but they allow us to accurately identify locations on the Earth's surface. And that's a crucial step in being able to do useful things with spatial data. We'll learn about many of those things during the rest of the course. So in summary, we'll use coordinates to describe locations on the Earth's surface. Different projected coordinate systems are used for different parts of the globe, and it's vital that we know which coordinate system a particular dataset uses.